Okay, so it's asking us to do this, yeah? Integral from 0 to infinity x e to the minus x cubed dx. Now, of course, this is a fairly complicated, huh? Right, this is a fairly complicated question to integrate. It's not easy at all. And what we could do here, we can make use of the definition of the gamma function. Okay, we can make use of the definition of the gamma function. So how do we do it? Well, we know that if you one of the formulas in your book, actually the definition of the gamma function says gamma of p is equal to 0 to infinity x to the p minus 1 e to the minus x dx, p greater than 0. Okay, the only problem is here I don't have e to the minus x, I have e to the minus x cube. Okay, so what I could do, I could take this x cube here and call it k, so I can line it up in this form. Yeah, because you know this is a dummy variable, because you know I if I can call this k and this k and this dk and arrange it to this fashion, I would still get, you know, this would still be the definition of the gamma function. Okay, so that means k is equal to x cubed, which makes dk equals 3x squared dx if you differentiate both sides, which means dx would equal dk over 3x squared. Okay, so now substitute into the integral. So we have, now of course, also notice that the bounds don't change. As x goes to 0, k goes to 0, because you know if you plug in 0 in x cubed you get 0, and as x goes to infinity, k also goes to infinity. So the bounds are not affected. So I can do this transformation as long as the bounds are not affected. So having said that, I would get 0 to infinity. I'm plugging it back into the integral. Now, if k equals x cubed, that means x is cube root k, right? So this becomes cube root k, right, which is k to the 1/3, and this is e minus x cubed, we called it k, so this becomes minus k, and dx is dk over 3x squared. But x is cube root k, so this becomes cube root k squared. Okay, and now all I have to do is rearrange it. So because there's a square here on the x, dx is, so I'm replacing dx with this guy, and then I replaced x with cube root k. Okay. I took the derivative of k because my integral needs to become dk, not dx. because I'm substituting k for x. So I can match it to the definition of the gamma function. This here is the definition of the gamma function. Yeah. So, okay, so some simplification here. So we have cube root k, and here you have cube root k square. So you are left with cube root k, which is k to the minus 1/3. Right? Which is k to the minus 1/3 times e to the minus k dk from 0 to infinity. Okay, now k to the 1/3 minus 1/3 is just p minus 1. Huh?
Wouldn't it be k to the plus 1/3? Isn't it just the cube root of k, not 1 over the cube root of k?
Right, it's 1. No, because it's in the denominator. Yeah, because it's dk over that. Ain't it? Look, you have cube root k over cube root k squared.
Yeah.
So it's in the denominator.
Yeah.
Right. So now p minus 1 is equal to minus 1/3, right? So p is equal to 2/3. 1 minus third. So that means this is the same thing as trying to rewrite it as p minus 1. This is 2/3 minus 1. This is the same thing as minus 1/3. From 0 to infinity, e to the minus k dk. So now I have it exactly as the definition of the gamma function, and that is just gamma of p, and in my case p is 2/3. So this here is just gamma of 2/3. And there's a 1/3 outside. So the final answer is 1/3 gamma of 2/3. So we were able to write that integral as a gamma function. So this would be the final answer. You see how to manipulate that from x dependency to k dependency, so you can put it in the form of gamma.